Hi everyone, welcome back to another session of our 10th class physical science part 2. We are going to talk about under the first chapter, reflection of light at a curved surface. In the previous session we were talking about some prerequisites which are helpful to understand the concept in a comfortable manner. So today also at up to particular instant we are going to discuss about the same prerequisites which we already studied in our 8th class, which are pretty good helpful for our discussion in this chapter. Okay. So first about yesterday in the last session, if you go with the revision of we were talking about what are the terms associated with reflection, what is reflection we understood, and what is the properties of light we understood, and what are the law of reflection. Two laws of reflection we plays an important role in our further discussion. That is, anguli is equal to anguli, and incident ray, normal and the reflected ray, all incident ray, normal and reflected ray, all three lies in the same plane. That is what we are going to discuss about, that we discussed about. For the continuation of this, we are going to discuss about how the plane mirror look like. Okay, we know everyone are familiar with our plane mirror. Okay, this is a plane mirror. Plane mirror, back of the plane mirror, if you observe the back of the plane mirror, there will be a painting. There will be painting. That under the painting, actually silver or aluminium. Aluminium is coated such that the plain glass is going to be converted into mirror. First we take plain glass and aluminium or silver is coated, and to seal it, a painting will be, this aluminium will be sealed with paint. To convert it as a mirror. Okay, generally we represent a plane mirror like this, and these lines indicate the back of the mirror. This is the back side of the mirror. Okay, and this side will be the reflecting surface. That will be the reflecting surface. Okay, this is the terms of that. And next one, we were talking about what exactly is the position of the image with respect to the plane mirror. What is the main criteria or what is the main concept which is helpful to understand the location of the image in front of the plane mirror. Okay, that is nothing but formation of image by a plane mirror. Formation of image by a plane mirror, that is what we were going to discuss today. See here, concentrate here all of you. Assume this is a mirror. I want to know, and this side is a reflecting surface. I want to know, this is the object. The dot is the object. I want to know where exactly is the location of this location of the image of this dot. Will it be here? Or will it be here? 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 Why, if it is this the image, why exactly we are going to get the image of the dot, this dot object at this point only? Why can't we this as why this cannot be acting as image? Why cannot this dot is acting as an image of the dot? Why cannot this all remaining? Why cannot they are acting like the images of that particular dot, this object? Is what we are going to discuss today. Okay. It's a very important discussion. So to identify, to trace, okay, there should be an incident ray is traveling, incident ray, and incident ray is hitting this mirror, and we are going to draw the normal to get the reflected ray. And if it is a 15 degrees, with the same 15 degrees, we are going to get the reflected ray. Where if you extend it backwards, this is a reflected ray, and if you extend it backwards, this is a reflected ray. Okay. Now one more incident ray I have to take. This is the incident ray, and I have to draw the normal. This might be at 40 degrees, 5 to 40 degrees. With the same 40 degrees, if I draw the reflected ray and if I extend it backwards, the intersection point of two or more reflected rays. Okay, so what does it mean is the intersection point of, very important statement, the intersection point of two or more reflected rays. Two or more reflected rays will be the location or position of the image. So the intersection point of two or more reflected rays will be the location or position of the image. Okay, with this respective dot, I need that intersection point of two or more reflected rays I want first. So this is the first incident ray, the respective first reflected ray. This is the first incident ray, that is a second reflected ray. If you go backward, they will be diverging. That is why I am extending it backwards such that there will be an intersection. This respective reflected ray, this respective reflected ray, as they are intersected at this point, that will be the location of that particular object's image. Okay, this is the image of the dot. So the main statement is the intersection point of two or more reflected rays will be the location or the position of the image. That is the main key point you have to keep in mind. Okay, that is wherever the two reflected rays gets intersected. Wherever the two reflected rays gets intersected, that is the location of the image. Simple. Okay. This is what is the main concept. Some prerequisites that we are going to discuss in our under the first chapter, reflection of light at curved surface. So we are going to talk about actual sense of actual topic of our lesson today. That is, what is the, so this is all, whatever we discussed, this is all with respect to the reflection of light with respect to the plane surface. We are going to talk about the curved surface. What is meant by curved surface? Okay, how do we get that curved surfaces? Imagine I have a transparent sphere, a transparent hollow sphere. Okay, this is a sphere. There will be a center for the sphere. For the sphere, there will be a center for the sphere. Now, what I am doing is, I am going to take some path. I am going to take some path. I am going to cut some path from the sphere. So from this sphere, I just cut some part. Okay, it is look like this. For example, it is looking like this. Okay, some part has been taken. If I coat the aluminium on the top, if I coat the aluminium or silver on the top and seal it from the top, the inward surface will be the reflecting surface. The inward surface will be the reflecting surface. So as it is a curved one, it's not a plane surface, it is a curved one. Okay, if I coat the silver or aluminium on the top, outer this bulge out region, and if I paint it, if I seal it with the paint, the inward surface will act as a reflecting surface. So if the reflecting surface, that is, if I seal it, and this inner surface is inward surface. If inward surface is the reflecting surface, if the inward surface is the reflecting surface, then such type of curved mirrors are called concave mirrors. So the reflecting surface is inwards. Inward surface is the reflecting surface. Then such type of curved mirrors are called as concave surfaces. Concave. Is it fine? Now suppose I'm coating the inwards region with the silver. I'm coating the silver inwards region with the silver or aluminium and sealing with the paint. Then the outward surface will be the reflecting surface. So generally this concave surface is represented like this. Okay, and if I draw this, inward surface is the reflecting surface. This is the paint. This is the silver or paint. And if the inward surface is painted, sealed, and the outward surface is the reflecting surface. If this is the reflecting surface, if the outward surface is reflecting surface. If outward surface is reflecting surface, then such type of mirrors we are calling as convex mirrors. That is, inwards it is painted as painted with the silver or aluminium and sealed with the paint. The outward bulge out region will be acting like a reflecting surface. Such type of mirrors we are calling as convex surface. Generally, it is represented like this. That is, inwards is painted. This is the reflecting surface. This is acting like a reflecting. That means there are two type of reflecting surfaces. Curved mirrors are there. That is concave mirror and convex mirror. Concave mirror, inwards region or inward surface will be the reflecting surface. Outward will be sealed with the silver and paint. Whereas convex mirrors, outward surface will be the reflecting surface, where inward surface will be painted with the silver and inward surface will be coated with the silver and painted with the paint, sealed with the paint. Okay, that is the difference. And why this is called as spherical? Because curved surface, because the reflecting surface is the curved one. As it is obtained from a sphere and the reflecting surfaces are the curved surfaces, they are considered as a curved mirror. Okay, so there are two types of curves. So from this discussion we can come to a conclusion that there are two types of curved surfaces or mirrors. First one is concave. Second one is convex. So concave mirror and convex mirror. I hope you understood this. What is the concern of the concave mirror and convex? Concave, the cave format or the inward surface will be the reflecting surface. Convex, the outer region will be the reflecting surface. That is the difference you have to keep in mind. Okay. Now we are going to understand about one important discussion about these reflecting surfaces. Very, very important discussion. So terms associated with this curved surfaces. Okay, very important discussion. Okay, terms associated with the curved surfaces is the topic today. Very important and interesting topic. We are going to discuss about the curved surface, concave. Okay, already we have a figure of this. The outward region is painted with the steel, and this is the reflecting surface. As the curved surface or a concave mirror is obtained from a sphere, the the geometrical center of this sphere is acting like a center of curvature. Center of curvature of the mirror. The geometrical center of the sphere from which the curved surface is obtained from is going to act as a center of curvature for that respective curved surface. Okay. So what are the terms first we will discuss about? First one is center of curvature. Center of curvature. The second one we are calling as pole. What is meant by pole? We are going to discuss about what is pole. Next we are talking about principal axis. Pole capital P. There is capital C. Principal axis. Next we are talking about focal point. Focal point capital F. Next we are going to talk about focal length. Focal length small f. And sixth one we are talking about what is the radius of curvature. Radius of curvature capital R. Radius of curvature we are going to talk about capital R. Okay. So among that first one we discussed about what is the meaning of center of curvature. Center of curvature, as the curved surface is obtained from a sphere, the geometrical center of that sphere from which the curved surface is obtained from, that is going to act as a center of curvature for that respective sphere. Fine. Next is pole. What is meant by pole? The exact midpoint on the sphere. Suppose this is on the curved surface. This is a concave surface. The exact midpoint, here is the midpoint. The exact midpoint which is located, the exact midpoint of a curved surface is considered as a pole. Okay, the midpoint is somewhere here. The midpoint of that is considered as a pole, P. The exact midpoint on the curved surface is considered as pole, and an imaginary line drawn from pole. And passing through the center of curvature. Imaginary line drawn from pole and passing through the center of curvature is considered as principal axis. Okay, imaginary line drawn from pole and passing through the center of curvature is called as principal axis. Okay. So center of curvature completed, pole completed, principal axis completed. Now focal length. The exact midpoint from the pole to the center of curvature. The midpoint. Okay, midpoint from the pole to the exact middle point between pole to the center of curvature. The midpoint to the pole to the center of curvature we are calling as focal point. We are going to discuss about focal point in detail. Okay, focal point is represented by capital F. So focal point is represented by capital F. This is a capital F, and the length between the pole and focal point is called as focal length. The length between the pole and the focal point is called as focal length. From here to here will be the focal length. Okay, and suppose if it is F distance from focal point to the center of curvature will be also F. So from here to here, as it is the midpoint, focal point is the midpoint. From pole to focal point, if it is F, this is the focal length. From F to C also it will be the same distance because it is the midpoint, and the distance from the pole to the distance from the pole to the center of curvature will be the radius of curvature. The distance from the pole to the center of curvature will be the radius of curvature. Okay? I hope you understood. So radius of curvature R is equal to F plus F. That is R is equal to 2F. R is equal to 2F. We use this in our problem solving. If the radius of curvature has been given, we use R is equal to 2F to solve some problems. Okay? So these are the 6 terms associated with the spherical mirrors. Okay. So as the sphere is obtained from as the curved surface is obtained from a sphere, the geometrical center of the respective sphere is acting like the center of curvature, and the exact midpoint of the curved surface is called as pole. An imaginary line drawn from the pole which is passing through the center of curvature is called as principal axis. The exact midpoint between pole and center of curvature. The exact midpoint between pole and center of curvature is acting like the focal point, and the distance from the pole to focal point. The distance from the pole to the focal point we are calling as focal length, small f. As it is the midpoint from this place to this place. From pole to focal point if it is f. From focal point to the center of curvature will be also f. And the distance from the pole to the center of curvature. The distance from the pole to the center of curvature we are calling as radius of curvature. The radius of curvature r value will be equal to f plus f, 2f. Okay, this is the relationship between r is equal to 2f is the relationship between the radius of curvature and the focal length. Okay, sorry. These are some terms associated with our curved surface. Generally, while drawing the ray diagram, we use the curved surfaces by this symbol. Okay, if it is marked like this, it is a concave surface, and if it is marked like this, we call this as a convex surface. Okay, representation we are not going to draw in a 3-dimensional view. We are going to draw in a 2-dimensional view while we are going our discussion further. That is in our further discussions, we are going to draw the concave surface and convex surface in 2-dimensional format. That is, this is the pole, and this is the center of curvature. This is the focal point, and this will be the focal length, and this will be the radius of curvature. For the convex mirrors, it is a convex mirror. Keep in mind that radius of curvature, focal point, and the focal length, and the center of curvature and radius of curvature will be on that side. It is not towards the reflecting surface. That is one point you have to keep in mind. For the convex mirrors, radius of curvature, focal point, center of curvature, focal length will be to the other side of the reflecting surface. That is one point you have to keep in mind. This is the terms and some important discussion about our curved surfaces. I hope you understood the terminology associated with the concepts. Very important discussion is this. Next topic we are going to talk about how the rays and how the image formation is going to take place with respect to the curved mirrors, how the rays are getting propagated towards the curved surfaces from any objects, how the image is going to form, how many there are different concepts we are going to discuss in detail in our further discussions. That's all for today. I hope you understood this. Keep in mind that it's a small review of, if you take a review, the location of the image will be always at the intersection point of 2 or more reflected rays. That is, wherever 2 or more reflected rays get intersected, at that point, the image of an object from which the reflected rays are coming from will be the image of that respective point. That is the main key point which is playing a role in our further discussions. And there are some terminologies with this. There are two type of curved surfaces: concave surface and the convex surface. Okay, this is a small review, and there are some 6 terms associated: center of curvature, pole, principal axis, focal point, and focal length, and the radius of curvature. There is a difference between the focal point is the point, length is from this place to this place. That you have to keep in mind. There is small difference in it. Okay. Thank you very much. I hope you understood today's session. Keep smiling, all of you. Have a good day. We will meet in the next session tomorrow. Okay. Thank you. Bye bye, all of you. Keep smiling. Have a good day.